Well, we've made it to our last lesson. Today's lesson is going to be section 2.5, solve for a variable. So here's our table of contents, and again, the date, today's date goes on the side. Alright, well, I'm going to be honest with you. Students tend to not like these problems very much. I think it gets a little confusing looking at everything that's going on. It says, for example, this first one to solve for p. So you notice you have a p, but you also have an m, and you also have an x. So to start off, that's confusing. The second thing is our answers tend to look a little bit confusing, and that will throw some students off. But what I'm going to tell you, just to make this a little bit easier, is don't worry about all the variables and how different your answer may look. What we're going to focus on is the operations, and we're going to undo every operation that we see. So for example, you can see I have a subtraction right here. That means I will end up adding. We have this division, we'll end up multiplying. One thing you'll notice is these problems tend to look familiar. So the setup of, this first problem, you're going to see a handful that look kind of like this. This second one, solve for m, you're going to see more than one that look very similar to this. So you're kind of going to get used to the pattern a little bit, but again, our focus, we're always going to go back to undoing the operations that we have in the equation. So if you guys have a big fraction bar like this, so you have a couple things, p minus 5, the whole thing is being divided by m. If you ever have an example like that, you are always going to start by undoing the division. Well, what are we doing? We're dividing by an m. The opposite of dividing by m is to multiply by m. And you're going to multiply by m on both sides. Actually, let me backtrack for a second. Usually, when I start this problem out, I say, figure out what you're solving for. It says solving for p, so I find p in the problem. I tend to circle it, and I know that I have to get that p alone. Alright, so back to the problem again. Sorry about that. We were subtracting a 5 and dividing by an m. So if you ever have a big division bar like this, a big fraction, you're going to undo that first. So opposite of dividing by m is multiplying by m. Now when you multiply by m on the left over here, these cancel each other out right away. So when you rewrite the problem, all that you have left is that p minus 5 on top. Carry down your equal sign. Now over here, x times m is just xm. We can't write it any other way but that. Alright, so now we go back to the p. We're trying to get this alone, and now we can see that we are subtracting 5. So we say, alright, I know there's a subtracting 5. The opposite of subtracting 5 is to add a 5. So I'm going to add 5 to both sides. The 5's cancel on the left, and you can see, just as I carry everything down, now I have p alone. P is going to be equal to whatever we get on the right side. Now, when you are adding, when you are adding something, you can only add it to its like term. So we want to say, is a 5 a like term with the xm? And we know that it's not, so we're going to leave it separate. On the right side, p is going to be equal to the xm, and then the plus 5 just goes on the end. We have p alone, so we're done with the problem. We may not like the fact that the right side is just an xm plus 5, but we're not going to worry about it because we did solve for p. We've done everything we can do. Alright, so our next example says solve for m. So let's figure out where m is. It's right here in the middle. Now, this type of problem, you will see more than one that looks kind of like this. We have t equals, you've got this fraction, 1/4 times m times n. So if you ever have a problem like this, the first thing I would do is get rid of that fraction. Let's multiply both sides of your equation by that 4. So we can do kind of that little fraction trick we've been working on. When you do 4 times this side over here, we want to remember that this is all one term. It's a 1/4 mn. So what we'll actually do is just multiply the 4 times the 1/4. So you can multiply 4 times 1 is 4, divide it by 4 is just 1. So it actually ends up just canceling out on the right side. So you're left with the mn. We want to make sure we multiply 4 times the other side, so 4 times t is 4t. All right, so let's go back to where our variable is. Variable m is over here. So what's happening to m? We are multiplying it by an n. Opposite of multiply by n is to divide by n. These n's will cancel over here. You can see we have the m by itself. I'm going to go ahead and write on the left side. So m is equal to that 4t over n. So on that example, we took care of that fraction first. That's going to be the way you're going to want to approach it, any of those. Fraction first, and then we divided by the n to get the m alone. All right, we'll just do 2 more, and then you guys will have some more in your examples. So solving for x. Solving for x, first find the x. It's right here. Look at the operations that is happening to x. Now, in this, you notice that we are multiplying by y, and we're also subtracting a 5. So if it gets confusing on which operation should you undo first, when you solve an equation, you actually follow PEMDAS, but in a backwards order. You start at the bottom and work your way up. If you're simplifying, you start at parentheses and work your way down, but if you're solving, we actually do start at the bottom and work our way up. So we say, well, do we have any addition or subtraction to undo? And I see, yeah, we have that minus 5. So the opposite of subtracting 5 is to add 5 to both sides. All right, your 5's cancel. Carry down your problem. We have xy is equal to, now this k and this plus 5, they are not like terms, so we can't put them together, so we're just going to leave them separate, k plus 5. All right, so we took care of that minus 5. Well, now we have multiplying by y. So what's the opposite of multiplying by a y? Dividing by a y. So we're going to divide by y on the left. Now on the right, do you see how we have these 2 terms? When you divide those by y, you actually want to divide the whole thing by a y. Did you guys notice this right here should be a y and I made it an x? Sorry about that. Divide by y. All right, so our y's cancel on the left. You can see that x is by itself, so x equals, and then on the right there's nothing we can do. Answer looks a little weird, but we got x alone, so we're okay with that. K plus 5 divided by y, and that is x. All right, so last one for our intro video, solve for y. So first we have to figure out where y is. And what are the operations with y? We're subtracting a 5. We're also multiplying it by an n. So going through PEMDAS backwards, what are we going to do first? We're going to undo any addition or subtraction. So that minus 5 goes first. Opposite of subtracting 5 is adding 5. So on the right, our 5's cancel. And on the left, when we added this 5, we actually have a like term that it can be combined with. We can put that 4 and the 5 together because those are like terms. So we'll rewrite this d plus 9, 4 plus 5 is 9, equals ny. We're still working on solving for this y right there, so we have to get the n to the other side, and it's being multiplied by n. So the opposite of that is to divide by n. And then if you notice on the left, see how we have those 2 terms again? We have to divide this whole side by n. So we're just going to do a big division bar, divide the whole thing by n. N's cancel on the right. You see we have y alone, so I'm just going to go ahead and write it on the left. Y equals, we have d plus 9 all over n. And even though we don't really like how it looks, that's okay. We have y alone. We've done the problem. We have solved for y. So these do get better the more that we practice those. You have a couple of videos with some more examples, but that's how you solve for a variable.